for class for the day. I am glad to see you all here. I hope you are having a great day. I want to remind you that today's class is recorded, like all of our courses. So if you do need to watch part of this class again, you can go ahead and do so by logging into our Moodle site. Now, I would like to start saying I was very impressed with all of the homework assignments I received. I received 7 assignments, so not everyone's turned their assignments in. If you didn't get your assignment to me before class today, please go ahead and send me your assignments. Not now, at the end of class would be fantastic. What we are going to do is I'm going to give you a brief overview of some really good things you guys did in the lab, but I'm not going to go into too specific because I want to see everyone's first shot before I do that. Fantastic job. Every single assignment I read was either typed or neatly written, so great job. All of the assignments I read had every single component or part that I asked for. You all had a title, you all had your hypothesis, your procedure, your results, your materials, your conclusion. Some of you added a little bit more. A couple of you put in some diagrams. Great thinking. I really appreciate the extra effort. Those of you who didn't, that's fine. I didn't ask you to. But a great effort on everyone's part. If you did turn your assignment in, it is graded. I sent it back to you in Moodle. You should be able to see your grade. This is an enrichment course, so I'm not giving you an A, B, C, D, F grade. I'm giving everybody who turns it in an A for effort. So you should see your grade as 100, and you should see some individual comments. I tried to get on your report in particular. Again, if you didn't turn it in, just go ahead and do so that I can see your fantastic work. Does anyone have any questions about the homework assignment or the lab from last week or the lab report you wrote? Brianna, go ahead.
I just wanted to ask about homework assignment because my mom said that we can either do it or not, and I think it just slipped my mind. So I was kind of asking about that, and didn't exactly get much information about it on the video from.
Well, the labs, in terms of being optional, they're not graded in terms of, like, I'm not going to give you a grade. You'll get a certificate of completion for the course if you come to 60% of the classes. The labs and the homework activities will make you understand the class even better. So whether you do it or not, that is a discussion for you and your parents. I would encourage you to do all of the assignments that I give you. But again, that is a discussion for you and your parents, and if they would like to talk to me about it, I certainly can talk to them on the phone. Any other questions about the homework assignments or the comments that I might have sent back to you? All right, then let's go ahead and get started with today's class. Today we are going to talk about graphing and a little bit more about the scientific method, which we went over last week. So we're going to start by reviewing the scientific method. I'm going to ask you a couple of quick poll questions to see how much of the scientific method you remember. So if you could answer these, that would be fantastic. Okay, the first question is going to be at you in 1 second. All right. If you could answer this in the poll, what is the hypothesis of an experiment? Is it your answer? Is it your best guess about what is going to happen? Or is it your research? What do you think it is? I see one answer. Keep them coming. What is the hypothesis in an experiment? Okay, I'm waiting for 2 more answers. Two more answers. Is it your best guess? Is it your answer? Or is it your research? Quick reminder to everybody, this class is a lot more fun if you participate in the class. Even if you're not 100% sure, take your best guess. Everyone is going to be wrong at some point, I promise you. The correct answer to this one, your hypothesis, is your best guess. Sometimes it's right, sometimes it's wrong. Most of us, I think, got the correct answer in the lab we did last week when we made our hypotheses, but you will not get the right answer every time. Okay, we're going to make another hypothesis today when we do our graphing activity, and we're going to see what we come up with for an answer. All right, next question. This is about the lab reports you wrote. Okay, where does your data go? Okay, here are your possible choices. In your lab report, where does the data, so last week it would have been the number of seconds that our Alka-Seltzer tablet took to dissolve. Where does that go? What part of our lab report? Great job, Mallory. What part of the lab report does your data go in? So it would have been the seconds that we recorded on our stopwatches last week. Okay, if you're not sure, take a guess. Okay, if you take a guess and you're wrong, oh well. You're wrong, not a big deal. All right, great job everyone. The correct answer is the results. And everyone who turned in their lab reports last week had the results in the correct spot. You had your data table, some of you, and some of you hand wrote out your data. You didn't put it in a table form, which is perfectly fine. There are lots of different ways to represent data. And that is going to lead us into what we are going to talk about today. So today we are talking about graphing. Graphing is a fantastic way in science and in math to represent your data. Now the lab we did last week, we could have graphed, but there really wasn't enough of it. So I made up some data, and we're going to practice looking at some graphs today, and then we are going to graph the colors in our M&M bags. So please do not open your candy bags yet. You might have M&Ms, you might have Skittles, you might not have anything. If you have a bag of candy, just put it right to the side for now, but we are going to use that today to practice our graphing, and whatever you choose to do with it after that is up to you and your parents. So let's take a look first at a PowerPoint about graphing. It should be up on your PowerPoint screen. It should say graphing in black letters. Why do we graph data? I'm going to make my video small and make my PowerPoint screen large now. If you would like to do the same, it will make it much easier for you to read the information. And a reminder how to do that, across the top of the PowerPoint screen, so right above where it says graphing, there's a purple toolbar. On the right-hand side of that purple toolbar, there's an arrow that is pointing up and to the right. Go ahead and click that arrow. My picture goes away, and you will see a large picture of the PowerPoint screen. So let's take a look about graphing and why we graph information. Why do we graph data? Well, when we graph data, we get to show our numbers. We get to show a picture. So here is a graph. This graph up here, I used data from 3 types of plants: bean plants, pea plants, and squash plants. And I measured and counted the number of plants for 4 weeks. Looking at this information, can somebody tell me, raise your hand, which type of plant had the most plants in week 4? Raise your hand. Which type of plant had the most plants in week 4? Brianna, go ahead.
The beans.
Fantastic. The beans had the most plants. It was really easy for Brianna, and I'm sure for the rest of you who rose your hands, to tell me that, because I had a graph. This is not a fancy graph. It's a very simple graph. There are a couple of parts to this graph that are very important. The first thing that is very important is the title. The title of this graph is Total Plants. A good graph always has a title. The second part that is important is my key. Does anyone know what the key in this graph is? Okay, this is going to be past knowledge. We have not talked about it yet. Raise your hand if you know what the key is in this graph. Elizabeth, go ahead.
It's the colors and information for the colors on the right of the graph.
Fantastic, Elizabeth. It is towards the right-hand side of my graph, and it is the little blue square that says beans, the little red square that says peas, and the little orange square that says squash. That is the key. It is telling me what I'm looking at. That is another very important part of our graph. The last 2 things that are very important on a graph are the labels of my axis. Now, axis you may be familiar with, you may not. There are 2 axes on every graph, an X and a Y. In this graph, the Y-axis has the numbers 0 through 9 on it, and it says number of plants. That is my Y-axis. My X-axis is across the bottom, and it has my weeks. The label on the x-axis and the y-axis tells you and me what I am looking at. Let's take a look at a couple of more graphs. Okay, these are the parts that I just explained to you. Would anyone like to read this slide for me? Raise your hand if you would like to read. All right, Alana, go ahead.
Graph title location at the top, axis titled horizontal, vertical, axis key. What are we looking at? Data. The numbers.
Thank you very much, Alana. Those are the main parts of our graph. And there's three types of graphs. There are line graphs, there are bar graphs, and there are pie charts. Those are the three most common that you will come in contact with. Once you get into upper level sciences, chemistry, physics, you'll come across a few different types, but you'll still come across these three types of graphs. Would anyone like to read this slide? All right, Zana, go right ahead. I'm going to try to spread it out a little. So if you already read something, don't raise your hand again until everyone's read. So Zana, this one is all you.
Line graph compares two things when the data is a quantity that varies with time. EX, plant, height, temperature. Bar graph compares two things when you are not looking for the trend over a period of time. Pie chart shows parts of whole, and there are only a few categories.
Very good, Zana. Thank you very much. So first, we're going to take a look at a line graph. Here is a line graph and some data. Okay, we're going to be done reading for a couple of minutes. So here's a line graph. I looked at plants in the sun versus the shade. That's my title. I have my key on the side that says shade and sun. Britton, do you have a question? Then across the X and the Y axis, I have my day and height in inches labeled. On the left-hand side, you can see my data table, and on the right-hand side, you can see my graph. Now, if I was to ask you which plant seems to grow Okay, Britton, you have a question? Go ahead. All right, for some reason I'm not able to hear you, Britton. If you have a question, you can go ahead and type it in the text chat to me, and then I can go ahead and answer it. But if I was to ask you a question, it's easier for you to answer it off of the line graph than off of the data. But now that I'm looking at my data, it looks like there is an error in my graph. So we're going to skip ahead here. Elizabeth, if you have a question, go right ahead.
The shade, my mom says the shade looks wrong. She thinks that the ones in the shade grew faster than the ones in the sun.
Yeah, I just realized that it looks like the data is wrong in there. So that was a good job pointing it out. Britton, if you don't know the name of the plant, that's okay. You can call them plant 1 and you can call them plant 2. You don't need to know the exact name of the plants. Great question, and thank you for pointing that out, Elizabeth. So when we do a line graph, we are going to plot this information together. So one of the things that I asked you to have for class today was a piece of graph paper. If you don't have graph paper, do the best you can to make even lines on a piece of paper. We are going to take our graph paper and we are going to graph this information on it. I am going to make my x-axis and my y-axis. My x-axis, so the one across the bottom, is going to be age. So I'm going to do age at birth is 0. So I'm going to label 0, 2, 4, 6, 8, and 10. And then up my y-axis, the one that goes up and down, I am going to do height in inches. Now, it has to go all the way up to 60. So I think I'm going to have every line on my graph be equal to 2. So go ahead and label your graph paper. I'm going to label mine, and then I will show you mine. If you have a question, hold on 1 second. Go ahead and label your graph paper. So here I have, if you want to make your screen so you can see me again, hit that little arrow and make it smaller. Okay, I'm going to answer your questions in 1 minute. I can see all your raised hands. Okay, here is my graph. I have across the bottom my x-axis, the age, and on the left-hand side, up my y-axis, I have height. So it looks like, Mallory, you had a question. Go ahead, Mallory.
I can't hear you or understand what you're saying.
Okay, let's check it out here. Okay, go ahead and answer the poll for me. Mallory said she's having a hard time understanding me. Is anyone else having a hard time hearing or understanding me? Yes or no? All right, Mallory, I'm wondering if maybe it's not your connection. Everyone else seems to be fine understanding. Did anyone else, you may want to try to log out and then log back in. That sometimes works. Did anyone else have a question? Go ahead, Brianna.
Oh, and my mom didn't tell me that we would need like the graph paper and stuff for this class. So, do you want me to do it with that I got, or is it?
If you have paper handy, you can just draw your own graph on. That's better than nothing. If you want to just follow along, that is fine as well. Elizabeth, you had a question as well?
How do you know what increments to put up the side of a graph?
Okay, that's a great question, Elizabeth. When you're looking at your data, for instance, this data, the tallest person or child is 60 inches. So I know, looking at my piece of graph paper, I don't have 60 lines going all the way up. So what I always try to do first is divide it by 2. And I think I have 30 lines. My graph of the same data could look different than your graph. If you did, maybe you printed this on a legal sheet of paper. So your paper was 3 inches taller than mine. And yours did go up to 60. It's not wrong. It's the same data. It's the same information. It just looks a little bit different. So the answer to your question is you never really know, and there's not really a wrong answer to it. You just need to use your best judgment. Shelby, you had a question?
What are you supposed to do again?
Okay, what we're doing right now is we're labeling our graph paper. So here is mine. Okay, part of your assignment in your syllabus was to have graph paper for today's class. If you don't have the graph paper, it's okay. You could just, and let me make one here, you can make just on a sheet of paper a line like this, and you can make your own graph. However, I'm going to show you on my graph paper because it's going to be much neater and easier to read. So right now, you're labeling your x-axis and your y-axis. The x-axis is the bottom or horizontal line, and I have that as age, the age of my children. And my y-axis going up the vertical side, I have the height in inches. I'm still missing 3 things from this graph. One of them is the data. What are the other 2 things I need to add to this graph that I'm showing you right now on the screen in order to make it a good graph? What other 2 things? Raise your hand if you know one of them. Elizabeth, go ahead.
You're missing the graph title, and you're missing the key.
Awesome job. I'm missing my title, so I'm going to write my title. I'm going to write height of children. That is my title. And I'm missing my key. Wonderful job. Now, for my key, I'm going to use squares for Sharon and circles for Alex. So I have added those to my graph. And I have my x-axis labeled. I have my y-axis labeled. I have my key labeled. And I have my title. when your graph looks like mine, click yes. Okay? When your graph looks like this, has the x-axis labeled, the y-axis labeled, the key, and the title, click yes.
I'm doing. I don't know what I'm doing.
Okay, all we're doing right now is we're labeling a piece of graph paper so it looks exactly like the one I'm showing you. Okay, it's up on the screen, so if you can't see my video, make it so you can see my picture. We're labeling our x-axis and our y-axis. We are putting a title up, and we are putting up our key. So your paper should look exactly like mine does. I'm going to give you guys about another minute to finish this up, and then we are going to graph the data. If you have this done and your paper looks like mine, you may start graphing the data that is in the PowerPoint. Yes, Ian, I counted by 2s for the height. Okay, so now what you are going to do is you are going to place your data on the graph. So at birth, Sharon was 17 inches tall. So I used a square for Sharon. I am going to, at the 0 on the x-axis or on the bottom axis, I'm going to go up to where the number 17 would be, and I am going to put a square. At birth, Alex was 20. So I'm going to go to where the 20 would be, and I'm going to put a circle. This is what that will look like on your graph. Let me zoom it in for you. Next to the 17, I have a square. Following the 0 all the way up at the 17, there's a square. Following the 0 all the way up at the 20, there is a circle. Now go ahead and finish plotting your data for Sharon and Alex. Remember, your graph may not look exactly like mine. It should look close, but it may not be exact. Once you have your numbers on your graph, you are going to connect the dots and the squares